My name is Pamela Perkins. I'm from Houston-Tillotson University, located in Austin, Texas. These past 10 weeks, I have done research with Notre Dame while being a part of the Data Intensive Scientific Computing RIU this summer under Dr. Paul Brenner as my mentor. This summer, my project was over 100-gig network analysis for high-energy physics. There is an increasing need to share big data for science research purposes on college campuses. Despite the availability of high-capacity networks, Notre Dame researchers are experiencing bottlenecks in their data transfers across a 100-gig network. Our goal is to tune the cyber infrastructure components to optimize performance of the 100-gig network while also keeping information highly secure within the Science DMZ. When tested, the highest single-stream point-to-point was sometimes high and sometimes low. But when several locations were tested within the United States and overseas, we found a significant correlation between growth latency and significant drop in bandwidth. There was no significant correlation found in the number of hops. With the help of ProfSonar, we have tested the network's performances by obtaining the following metrics. The amount of achievable bandwidth, which is available to move data, which is quantified in megabits per second. Also, round-trip latency, which is the amount of time it takes to receive a packet to and from across the network. And the path data transit, which is a traceroute tool, which is measured with the number of hops between points in the network. I identified factors that cause poor network performances: the presence of a bottleneck, high bandwidth delay products on long fat networks, and network throttling that could occur especially from outside the United States. To illustrate this later issue, I contacted one of the test points in China to learn about their network connection. The results was China was able to move at least half a gig between us, and we were only able to move about 76.3 megabits to them. With that being said, here's a correlation graph that shows when several locations were tested within the United States and overseas. Correlation does not mean causation, but it is helpful to find out there is a connection between the two. Our future work entails cleaning up the network bottleneck issues, finding ways to reduce throttling, reduce the clutter by adding a couple more servers, and keep our data safe by increasing the security with our transfers. We hope to be a highly secure but also a very fast 100-gig network. Based on the 100-gig top 10 physics sites from which we pull data from, and given the aggregate is about 17 gigabits per second, I have came to a conclusion that adding a couple more cache servers will enable the network to run more efficiently. Without the help of Dr. Paul Brenner, Dr. Kevin Lannon, and Dr. Douglas Stain and Kenny, none of this research would have been possible. Again, thank you.